Hey there, seventh graders. It is Mrs. Antos. We are moving on to 9.4, Introduction to Three-Dimensional Figures. So today is a really nice lesson. It's just very straightforward. We're going to look at some different shapes and learn how to name them and learn about faces, edges, that kind of thing. So you do need a couple note cards. I believe there's 4 note cards for this one. So make sure you're taking notes like you normally would, and also make sure you have your note cards. Now, the notes, it might be a little bit difficult to draw some of these shapes. So if you just want to write down key points, you can always refer back to this video anytime you need it, okay? Also, for the homework, 10, 11, 12, there might be a few at the end where there are multiple answers to one question. Like number 10, 11, and 12, they ask the number of faces, the number of edges, and then what the shape name is. So I put 3 different spots for you to put those answers. So make sure you're paying attention to that when you input your stuff into Google Forms. Okay, let's get started. Let's see here. Okay, so when you're talking about a 3-dimensional figure, okay, there's going to be obviously 3 dimensions. There's going to be length, width, and height that's involved. And we're no longer looking at just like a flat surface. We're looking at the entirety of a shape. So where you have a flat surface, it's called the face. Okay, the face is anything, and I have some of these from my classroom that I brought. Anytime you have something like this where it's a flat surface on this 3-dimensional shape, it's called a face. Okay, the edges are where those faces are going to meet. So these are the edges. Okay, so that's the first couple of definitions that you're going to need for this. Okay, next, a polyhedron. So a polyhedron is a 3-dimensional figure whose faces are all polygons. If you have a polyhedron, when you have the points where they're meeting, where 3 edges meet, so again, if you look at my shape here, we have an edge, and an edge. This point right here where they meet is called the vertex, okay? The face that is used to name the polyhedron is the base, okay? And we'll talk more about that in a minute. So, excuse me, when you have a polyhedron, we're going to name it in a certain way. The base shape is part of how we name this, okay? The next part too, we have prisms and we have pyramids. Prisms are going to have 2 bases and pyramids will have 1. So once we go through some examples, we'll show you what that means and kind of how to get that named in what we're doing. Okay. So again, here's another note card. So I lied. I think I said 4. I think we're up to 6 now. Okay, so the next note card or next definition, a prism is a polyhedron that has 2 parallel congruent bases, and the bases can be any polygon. All the other faces are parallelograms. Okay, so the key here is that it has 2 bases for the prism. Pyramid is a little different. Think about the ancient Egyptian pyramids. They have a base. They have that one base on the bottom, and then they all meet at a point up on top. Okay, all the other faces are triangles. So there's some differences. We have a prism that has 2 bases with the faces being parallelograms. Then we have a pyramid that has 1 base and the faces are triangles. Okay, so keep those 2 distinctions in mind. When you see the shapes, you'll be able to determine and look at, hey, is this a prism or is this a pyramid? Okay, so this is the part where it's going to get kind of hard to take notes. So if you just want to watch, maybe jot down some key words that'll help you remember when you go to do the homework and when I assess you on this in a few weeks. What we're going to do for the next few slides are identify the bases and the faces, then we're going to name the figure. Okay, so if you look at this, this is kind of hard to see, but if you count, so this spot right here, this is facing towards you. That's one of the bases. Okay, the other base is back here. All these other rectangles that connect the two bases, those are your faces. Okay, so if I look at my base, I'm going to count how many sides do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I have an octagon. So my base is an octagon. Okay, you have two of them. You have this one that's facing you and this one over here. Okay, and then you have 8 rectangular faces. So 1, 2, 3, 4, 5, 6, 7, 8 rectangular faces that are connecting those two bases. Okay, so if you recall back a few slides, how we name this is by looking at the base. We name the base, we name the polyhedron based on that base. That's a lot of base going on there. So our base are octagons. So this is an octagonal prism because we have two bases. Okay. All right, next. Okay, this point right here is a dead giveaway of what we got going on. But let's take a look. The base is down here. That's a pentagon. It has 1, 2, 3, 4, 5 sides. Okay, so the pentagon has 5 sides and it's connected by 5, what are these shapes right here? 5 triangular faces. So this is called a pentagonal pyramid because it comes to a point, because it has one base, because it has triangles for the faces, it's a pyramid. So you first start off by naming it with your base, which is a pentagon, so pentagonal, and then you figure out if it's a prism or a pyramid. This is a pyramid, so it's a pentagonal pyramid. Okay. This one's a little harder to see and to kind of, I don't know, I don't really like this three-dimensional model, but again, this is coming up to be a point up here. The base is a triangle and it's got 3 triangle faces. So this is a triangular pyramid. Okay. Next, right off the bat, I'm looking at this. This is a prism. It's got one base here, and then right behind it, it's hard to tell, is another base there. Let's see, what do we have? 1, 2, 3, 4, 5, 6 sides. So we have a hexagon. This is a hexagonal prism. Notice how when you see how many sides they have, that also tells you how many faces they're going to have, right? When you count up the sides of the base, that's going to tell you how many faces you have. Okay. Ooh, I like this one. Okay, this one is interesting. You have to be very careful with what you're looking at. Okay, we have 2 bases going on here. You're tempted to want to say this square, I think it's a square, might be a rectangle, that this square is the base. It's not. Okay, there's more than 2 of them, so it cannot be the base. We have 1 triangle here and a triangle back there. So our base are actually triangles. We have 2 of them, so that means that it's a prism. And there are 3 rectangular faces. You guys, okay, they are rectangles. I thought they were squares. But so here's a rectangle, and this on the quote bottom is a rectangle as well. The bottom, top, sides, those are all kind of relative terms because it's 3-dimensional. You can move the shape any way you want, right? So be aware of that. So this is a triangular prism. Ooh, I like this one. Again, we have a prism. Now look, all of the bases and the faces are congruent. And if we recall back from last chapter, congruent means equal. Same dimension. So this figure is a cube. It has a special name. You guys all know what a cube is. You've seen a cube a million times. When you roll dice for any board game or whatever card game you're playing, that is a cube. Okay, so now we're going to move on to another type of three-dimensional figures. These are not polyhedrons. So everything we talked about before, if it was a prism or a pyramid, those are polyhedrons. The things that we're talking about now are not polyhedrons because they're not made of polygons. Okay, all their faces are made of different things. So here we go, 3 more note cards. Gosh, I really lied to you. So what are we up to now? 9 maybe? 9 note cards. So next one is a cylinder. A cylinder has 2 parallel congruent bases that are circles. Okay, a cylinder can be anything. It could be a can of soup. It could be, I don't know, what's another cylinder? Something that fits into like your Legos. A cylinder can have it can be anything that has 2 circles on the top and the bottom, okay? A cone, think of an ice cream cone. A cone has 1 base, which is a circle. So if you're looking at an ice cream cone, the base is like inverted up, right? The base is a circle, and then the rest of the surface comes to a point, and that's what makes it look like a cone. And then a sphere is simply just made of all the points that are the same distance from a given point. That's just a fancy way for saying it's essentially like a 3-dimensional circle. It's kind of like a ball, a basketball, a baseball. Those are all spheres. Okay, so the properties that you're going to use, whoops, I meant to go backwards. You can use properties to classify 3-dimensional figures, which means it just telling you what we have going on, okay? So actually I want to go back. Hopefully you guys can hear me. The neighbor is mowing the lawn. It's really loud up here in my bonus room. So this is an example of a cylinder. You guys see this? This has a circle over here for a base and another circle for a base, and the rest of the surface area connects those 2 circles. This is a little bit of a bigger cylinder. This kind of reminds me of like a candle that you might have sitting around at home, or mom and dad like to burn candles, or we have some flameless candles. This is what reminds me of it. There's 2 circles. Here's a circle, and it's connected with the surface area to create that 3-dimensional shape. Here's a cone. Okay, if you look at the cone, again, the base is the circle, and the rest wraps around that circle. It creates a point. If you can see that point, I'm trying to find a good spot for you to see that. There we go. The point. So this is a cone. You can think of it as an ice cream cone. You can think of it as a birthday hat. And then finally a sphere. So this is just pretty straightforward. It's just a circle, right? A 3-dimensional circle. It looks like a baseball, tennis ball, soccer ball, what have you. Okay, now, if we look at this to determine if this is a polyhedron or not, so we can actually separate this figure into 2 different shapes. We have every single face on here are polygons, so this figure is definitely a polyhedron. We have the top portion here is a rectangular prism. The base is a rectangle, right? And there's only 1 base, so it's a prism. And then over here we have a rectangular, I'm sorry, did I say prism? This is a rectangular pyramid. My bad, because there's 1 base. And then this is a rectangular prism here on the bottom. Okay. Okay, next. If we look at this one, wow, that's kind of hard to see. Hopefully you guys can see it a little better on the webcam. That's a cone. This is not a polyhedron. There's 1 circular base, so we're literally going to name it a cone. Okay, it's that straightforward. This is also not a polyhedron. This is a cylinder. The cylinder has the 2 circular bases, and so therefore it's not a polygon, not a polyhedron. Okay, same thing here. We have a cylinder and a cone, not a polyhedron. Okay, so that's about it in a nutshell. Your homework is 7 to 21. Actually, it's all, not odd. So just follow whatever it said on the Google form. Okay. And